We talked about ionic compounds and how to name them and write their formulas. The other type of compound is the molecular compounds. Molecular compounds, remember, consist of two or more nonmetals and they're bonded together with covalent bonds. Because there are no charges on the ions to tell us how many of each ion to put together, we can't just know what the formula is for a molecular compound by looking at its constituent elements. We can do that for a lot of the ionic compounds. As an example of why that doesn't work, nitrogen and oxygen form at least 6 different molecular compounds. There's my favorite compound, no. It's all caps, it's yelling, right? No. There's NO2, N2O, N2O3, N2O4, and N2O5. So the compound between nitrogen and oxygen, there's at least 6 of them. So we can't just call it nitrogen oxide. That's just not going to work. Again, molecular compounds, the ones we're going to learn how to name, are composed of 2 nonmetals. If there's 3 elements in there, it's something else that we're not going to learn. If it's 3 nonmetals, we're not going to learn how to name that in this section. So we use numerical prefixes to indicate how many atoms of each element are present. These are the numerical prefixes. These are used in lots of different areas, and so you should be familiar with those. If you're not, please memorize them. One that might be new is tetra, and hepta is kind of odd as well. Usually we put the more metal-like element first. So we learned that the metals are on the left side of the periodic table and generally lower, and the nonmetals are on the right. So if you have to choose, if you've got nitrogen and oxygen, nitrogen is closer to the metals, and so it's listed first. I'm not going to try to trick you on that, but some of you might wonder, why is it nitrogen monoxide and not oxygen mononitride? Because, wow, that was hard to say because that's so backwards. So when we name these, we have the name of the first element. We put a prefix on the front to indicate how many. We have the name of the second element, and this resembles the ionic compounds in that we change the ending of the second element's name to "ide." Okay? We put a prefix on that to indicate how many. Now, just like we've eliminated the number 1 in several other areas, if there's only one atom of the first element, the prefix mono is generally left out. So, for example, NO2, instead of calling it mononitrogen dioxide, we leave the mono off the first one. Frequently for the second element, the mono is used. Okay? 2 that have special names are H2O and NH3. They always use their common names, water and ammonia. So if you call water dihydrogen monoxide, I will understand what you mean, but even chemists don't call it that. That's just something fun we use to trick our non-science friends. I thought I was going to die today. There was so much dihydrogen monoxide all over the place. It was raining. You can scare people that way. So these 2 special names. So let's do a couple of examples. Name the compound N2O5. Dinitrogen pentaoxide. Dinitrogen pentaoxide. Now, what you'll see sometimes is that when we have a double vowel here, sometimes the A on penta might get left off. There doesn't seem to be a great rule to remember when that should happen, and I will not try to trick you on that. I won't, if you spell pentaoxide without the A and it should have the A, I won't mark it wrong or anything. Just know that there's a little ambivalence in there. What's the formula for phosphorus tribromide? Phosphorus has the symbol what? P. How many phosphorus atoms are in this? 1. It doesn't say monophosphorus, but it doesn't say anything else either. So 1 phosphorus, and then bromide is Br. You guys need to wake up. How many? 3. So the number goes after in the formula. The prefix goes before in the name. Because prefix, pre means before. Prefix has to go before. Any questions? Naming molecular compounds is usually the easiest one. Students don't tend to have too much trouble with this. The problem is you like this so much, you try to apply it to other types of compounds. So resist that temptation. Acids. Acids are molecular compounds. Some of them, we'll see, are composed of two nonmetals, hydrogen and another nonmetal. But acids are special, and so because they fall in a special category, they have a special set of naming rules. One way to define an acid is that it's a molecular compound that releases hydrogen ions when dissolved in water. When you put an acid in water, it forms ions, but before you put it into water, it is not an ionic compound. Ionic compounds contain metals or ammonium, and so these are not ionic compounds. We can recognize formulas for acids because they always start with H. So if you see the first element being H, that means it's an acid. The nice thing about Chem 1A is we can leave out some of the exceptions. So in this class, starts with an H, it's an acid. So HCl, that's a molecular compound between two nonmetals. When you put it in water, it forms hydrogen ions and chloride ions. This AQ stands for aqueous and just means that it's dissolved in water. A compound is not considered or named as an acid if it is not dissolved in water. If the compound will not dissolve in water, you don't name it as an acid. So if HCl was in its pure form, which is a gas, if we see HCl in the gas state, that would be named as a molecular compound. What would its name be? Hydrogen. We really should put the mono in there, monochloride. And named as an acid, it's got a different name when it's got the AQ. I'm not going to try to trick you on that. I say try because I may accidentally trick you, but it's not intentional. Characteristics of acids. You'll talk a lot more about acids in Chem 1B, but we don't really talk too much about acids except for in this one little section here. Acids typically taste sour. Sour Patch Kids, the candy is sour because it's got acid on the outside. I think it's malic acid and tartaric acid. Acids will dissolve many metals, but not all of them. They'll dissolve things like zinc, iron, magnesium. They will not dissolve gold, silver, or platinum. So this is the sort of thing that happens when you put zinc metal into an acid. It forms hydrogen gas and zinc ions. The formulas generally start with H. So those are a couple examples. Okay, two types of acids, and they're named according to different rules. I'm not a fan of this name, binary acids, because there are a couple that fall in this category that have more than two elements. But generally, binary acids, only two elements. Oxyacids, these are compounds that start with H, and they have oxygen in them, in addition to another element. So it's an acid, but it has oxygen in it. So I prefer to think of it as the oxyacids and the other ones, because that covers everything. So let's look at the binary acids first. Binary acids use the prefix hydro. Then you take the base name of the nonmetal element in there and you change the name to ic and you throw the word acid at the end. So here's an example, HF with AQ after it. That tells us we're supposed to name this as an acid. This is a binary acid. It doesn't have any oxygen in it. So we use that prefix hydro. And we take the element name fluorine and we change its ending to ic, fluoric, hydro, fluoric, and the word acid. Any questions? From their names, acids are ridiculously easy to recognize because they actually have the word acid in their name. How convenient is that? Okay, the oxyacids. The oxyacid names are based on the names of the oxyanions. Those are those polyatomic ions that you're supposed to memorize. You look at the ending of the oxyanion's name. If it ends in "ate," you change the ending to "ic." If it ends in "ite," you change the ending to "us," and then you put the word acid on it. Actually, let me show you my. There's actually two different sentences. So you've got "ic" and "ate" and "ite" and "us," and you have to remember how they go together. Fighting with the stylus. So a silly sentence is in order. Rick ate him before he could bite us. Is that silly? So there's the "ic" goes with "ate," and the "ite" goes with "us." "Ic" and "ate" go together, "ite" and "us." The other one that some people use is "the white mouse ate icky cheese." So there you've got your "ite" and your "us" or "aus." White mouse ate icky cheese. If you come up with another one, you're welcome to use that. You just have to get them paired up in your head. Okay, so let's name this one HNO2. So when we're naming compounds, the first thing we have to do is identify what kind of a compound is this. Now, obviously, this is an oxyacid because of the title on the slide, but let's pretend we didn't see that. Look at the first element. Is it a metal? No, so it's not an ionic compound. Is it hydrogen? Yes, therefore it's an acid. Is it an oxyacid? Does it have oxygen? Yes, it does. If it didn't have oxygen, then we'd use the hydro-blank-ic acid formula. But this has oxygen in it. So what we want to do is identify the name, the name of this guy. NO2 minus, what's his name? Nitrite. It's the light version of nitrate. Nitrite. So we're going to change the ending "ite" to what? Us. Bite us. So this is going to be nitrous acid. Any questions? We don't use the prefix hydro here. Write the formula for perchloric acid. So perchloric, ic came from which ending? 8. This came from perchlorate. Well, what's the formula for perchlorate ion? ClO4 minus 1. Chlorate is ClO3 minus 1. Perchlorate has an extra oxygen. What charge does hydrogen have as a positive ion? What group is it in? +1. It's in group 1A. It does form a +1 ion. So perchloric acid comes apart or forms these ions when it's put into water. We can use the charge on the hydrogen ion and the charge on the anion to know how many hydrogens do we need to put with this. So since perchlorate is a -1, we just need 1 hydrogen, and this is perchloric acid, and then it's a nice touch to put AQ on there. Any questions? What would the formula for sulfuric acid be? Sulfuric comes from sulfate, right? Sulfate is SO4. What's the charge? 2 minus. How many hydrogen ions does that need? It's 2. So sulfuric acid would be H2SO4. Any questions? This is something you have to practice or you won't remember it. So I kind of already did some of this, but writing formulas for acid. So when you see the name that has acid in the name, then you know it's an acid, right? So you know the formula is going to start with H. You're going to write the formula out as if it were an ionic compound, even though we know it's molecular. Hydro prefix means it's a binary acid. No prefix tells us it's an oxyacid, and so we just reverse the pattern here. Instead of going from 8 to ic, we go from ic to 8. So here's some practice writing formulas, extra examples. Okay, hydrocyanic acid. What does the prefix hydro tell us? It's a binary acid. I prefer to say it's not an oxyacid. So it's not an oxyacid. Cyanic, CN, that's from cyanide. And what's the charge on that? It's a -1. So this is one that is named as a binary acid, even though there's 3 elements in it. That's why I don't like that name. So we would need 1 hydrogen to put with that. And so the formula for hydrocyanic acid would be HCN, aqueous. It's not an oxyacid. It has a polyatomic ion in it, but it's not an oxyacid. There's no oxygen. So that's the one that's kind of confusing. How about phosphoric acid? What's the well, first of all, binary or oxyacid? Oxyacid. Doesn't start with hydro. Phosphoric is from what? Phosphate. PO4 3 minus because you memorized it. How many hydrogen ions does that need? 3. It's the same as the charge. Right? The charge is 3 minus. That tells me I need 3 hydrogen ions because they're each +1. So phosphoric acid, H3PO4. How about hypochlorous acid? What kind of an acid is it? Oxyacid. So the prefix hypo is a lot like the prefix hydro, but it's not the same. Hypochlorous comes from which anion's name? Hypochlorite. Hypochlorite. Formula for hypochlorite is ClO minus. So what's the formula for the acid? HClO. Because there's a -1 charge, it's going to have 1 hydrogen ion with it. Any questions? So acids are things, molecular compounds that form hydrogen ions when dissolved in water. So there are some pollutants, particularly these guys, nitrogen monoxide, nitrogen dioxide, sulfur dioxide, and sulfur trioxide, that when they get mixed with water, like is present in the atmosphere and as rain, result in the water, the rain that falls being acidic. And that can cause a lot of problems. Acids are corrosive, and so here we see some old statues, but this one was exposed to rain more than this one, and you can see that it's just kind of getting dissolved by the acid rain. Acid rain also kills trees. So it's not that people are putting acid into the atmosphere, but some of these pollutants combine with water to form acids. So that's where the acid rain comes from. I won't test you on acid rain.